You ever stop and think about the invisible magic that powers our modern world? You know, how your phone just knows to rotate its screen, or how an automatic door glides open like it read your mind. It feels totally seamless, almost like a sixth sense. But it's not magic. It's this incredible network of tiny, unseen parts. And today, we're going to pull back that curtain and show you exactly how it all works. So what's the deal? What actually makes a smart device, well, smart? What gives it that power to sense the world around it and react? The answer is way smaller and a lot more common than you might think. The secret is right here. These little electronic components, they're the real heroes of our digital world. They are the invisible eyes, ears, and even the nerve endings of our technology, giving our devices this incredible ability to feel the world. Okay, so to really understand how this all clicks together, we have to start with the most basic building block. So what exactly is a sensor? At its core, the idea is actually pretty simple. A sensor is just a device that measures something physical, like heat or light or motion, and then translates that information into an electrical signal that a computer can understand. Think of it like a translator, creating a bridge between the physical world and the digital one. A perfect example is something we've all used, a mercury thermometer. It's a simple, old-school sensor. It measures the physical thing, temperature, and the mercury rising gives us a really clear visual signal. Well, digital sensors work on that exact same principle. They just use electrical signals instead of liquid mercury. Now, sensors basically come in two main flavors, active and passive. And the difference is really all about power. Active sensors need an external power source, like a battery, to get the job done. Passive sensors, on the other hand, are kind of self-sufficient. They actually generate their own signal by grabbing energy from the world around them, sort of like how a solar panel turns light into electricity. All right, now for the really cool part. Let's take a tour of some of the most common sensors out there and see exactly how they give our machines their senses. And wow, the variety is just incredible. I mean, from temperature sensors in our smart thermostats to the gyroscopes that keep drones perfectly steady, each one is a specialist, designed to perceive one specific slice of reality. What's amazing is how they're just woven into the fabric of our daily lives, and most of the time, we don't even notice. First up, let's talk about the sense of presence. How does a machine know you're there without you ever touching it? Well, it uses a proximity sensor. Here's how it works. It sends out this field of energy. It could be infrared light or maybe an electromagnetic wave. When something like your hand or your car enters that field, the sensor detects that disturbance and triggers a response. All of this happens with zero physical contact. Pretty cool, right? And seriously, once you know what to look for, you start seeing them absolutely everywhere. They are the things in the automatic doors at the grocery store, the parking sensors in your car that beep like crazy, and even the touchless faucets in a public restroom. They are quietly making our world so much more interactive. Next, let's look at how machines sense motion. This is a huge one, especially for stuff like security and being energy efficient. This little guy is a PIR, or passive infrared sensor. It's passive because it doesn't send out any signals of its own. Instead, it's more like a silent watchman, just constantly scanning for infrared radiation, which is basically the body heat that we all give off. When it sees that heat signature move, it springs into action. This is the exact technology behind a home security alarm that would detect an intruder. It's also used in smart lighting systems that flip the lights on when you walk into a room and turn them off when you leave, which, by the way, saves a ton of energy. But what about a device sensing its own movement, its own orientation? Well, for that, you need a dynamic duo, the accelerometer and the gyroscope. Together, they give a device a sense of its own body in 3D space. The gyroscope is the master of orientation. Its whole job is to measure rotation and tilt on any axis. This is absolutely critical for keeping a device balanced and knowing which way is up. Just think about it for a second. An accelerometer in your fitness band is what's counting your steps. It feels the jolt of your movement. A gyroscope in your smartphone is what knows to flip the screen from portrait to landscape. And in a drone, they're the only reason it can hover perfectly still instead of just tumbling out of the sky. Okay, for our last stop, let's talk about sensing the invisible. Our world is full of gases we can't see. Some are harmless, but some can be really dangerous. And that's where gas sensors come in. These sensors are, and I mean this literally, lifesavers. They're inside the carbon monoxide detectors in our homes. They're used all over cities to monitor air pollution levels in real time. And in factories, they provide that crucial early warning for dangerous gas leaks. Okay, so we've seen how all these individual sensors can give machines very specific senses. But what happens when you start to connect all of these senses together? This is where it all starts to get really interesting, because each of these tiny, specialized sensors is like a single Lego brick. On its own, it's pretty useful, but when you start snapping them all together, they become the building blocks for something truly transformative. And that bigger thing is the Internet of Things, or IoT. When you connect billions and billions of these sensors to the internet, you're essentially creating a planet-wide sensory system. They become the digital nervous system for our entire connected world, constantly feeling, measuring, and reporting back. So that leaves us with one last kind of mind-blowing question. We've given our world a nervous system that can sense temperature and motion and location and even the very air we breathe. As these sensors get even smaller and smarter and more deeply embedded into everything around us,